Hey everybody, Dave Lindbergh in Hong Kong with another episode of the THD Podcast. Today, joining us from Austria, we have USound to give us an update on their technology and tell us some of the progress they've made in the last year. So we're looking forward to an overview on their MEMS speaker technology. But without delay, let's not forget about Alti, our sponsor, the Audio Loudspeaker Technology International. We encourage everybody to join that organization. It's great for networking and getting connected to different elements of the audio manufacturing supply chain and industry. So without delay, we've got Simon in Japan. How are you doing this afternoon for us, Simon?
Good. Weather's got hot over here now. We're into the high temperatures of summer.
Okay, great. And joining us from Austria, we have Paul Kutschera, the VP of Sales, and Andrea Rusconi, the CTO. How are you gentlemen doing?
Good. Thanks, Dave. Glad to be back.
Okay.
Thank you, David.
All right. So yeah, we met first time on the podcast about a year ago, but we decided let's get back with USound, and MEMS speakers is a growing topic in a lot of different applications in consumer and all kinds of different areas that where audio normally wasn't placed. So how about we get into a presentation and just go over where you guys are at today?
Okay, thank you. As you said, the last time we spoke was roughly a year ago, where we're about to introduce our round Conamara series. Today, I'd like to give you an update on what's happened in the last year, both on a funding base, but also on the customer base. And then Andrea will actually give a little bit of an update on what's happened from a technology point of view. So the biggest announcement we had last year, end of last year, beginning of this year, is we had another series of funding where we raised $30 million, 25 million euros from various investors. This was a good investing round because we're using this money right now to ramp up the production of a couple of customer projects we have won in the past year in various application fields, mostly in TWS and augmented reality, which is still our main focus, paired together, of course, with audio classes, which we produce on our own under the brand Fauna. So, with no further delay, I'll give you an update on 4 major customer projects we have won. 2 of them I can actually name. 2 of them we're still under NDA, where I can't tell you the brand, but I'll give you an idea on when they will ramp up. Before starting with those, we've also extended our cooperations, mainly with the Austrian manufacturer of PCBs, AT&S, where we are producing an audio module which can be integrated into TWS. They have really good manufacturing of PCBs, and we are able to integrate speaker on a flex PCB together with an amplifier. And from a production perspective, we have shifted the production to the Italian company Elemaster, who is now producing our Ganymede series. This was mainly due to supply chain issues we've seen in the last year and which are still ongoing. We just want to be closer to our headquarters and therefore manufacturing in Italy. This is roughly a 5-hour drive. So in the customer projects, what we've seen, we've ramping up at the moment a TWS project with a major consumer smartphone electronic brand, and those guys, they selected the Conamara series, which I announced last year, which is a round MEMS speakers, which comes in different sizes. We've been working with those guys for over 2 years in optimizing the speaker to exactly their demands. So it's an exclusive product for this company, and we're using the 6mm round speaker there as a tweeter, and this is basically following a trend we've seen in TWS that the consumer electronic brands are shifting to a 2-way audio system, and for those applications, a MEMS working as a tweeter is the ideal solution. You can see this in the picture below from the form factor. we're using the MEMS as a tweeter, and this is then paired with an electrodynamic woofer, which is from the picture very visible, way larger than the MEMS speakers. They've selected us mainly because of the form factor, the bandwidth. The Conamara series is also IPX8 rated, so it's easier to integrate. It's easier to actually get an IP rating on the whole TWS earphone. The Conamara series is solder reflowable, so the production will become easier, and it's also of course weight and vibration, which is way better than with a standard balanced amateur speaker you would normally use in such systems. This product is going ramp up in Q3. We're starting ramping up right now. The customer itself expects that the product will be in the market Q1, maybe Q2 next year, but they're starting production right now.
Mm-hmm.
Moving from TWS, we've found an application where headphones so far haven't been used that much. This is magnetic resonance imaging devices. We are here working with in total 3 companies, but this is the one I can name. Nordic NeuroLab is developing an over-the-ear headphone using the Ganymede series, in detail the UTP 2016 version, in an array to be used in an MRI machine. So far it has been a problem using headphones there because there is ferromagnetic material in the speakers, and this is something that just can't go into an MRI. And the UTP 2016 version has actually no ferromagnetic material. So they're using those in an array to both cancel out the noise an MRI machine is actually making, and this can be quite loud. This can go up to 120, 125 dB on a peak.
Wow.
But it is also necessary that the technician who is actually performing the scan can communicate with the patient easily and clearly. The reason for that is an MRI scan, at least in the US, is very, very costly. So they can go up to $4,000, $5,000 per scan. And the huge problem they have is that patients are dropping out of mid-scan, and they need to reschedule the scan, therefore adding actually cost. The tube is very, very narrow. If you feel claustrophobic, and the moment you can hear music or have the possibility to talk to a technician, people tend to calm down. Less scans are getting cancelled, and therefore the company who is actually providing the scans can schedule more scans per day. And that's the reason why a good audio in such MRI machines is very crucial. And as I said, main USP here is that the Ganymede series, the UTP 2016, is having no ferromagnetic material inside.
Wow.
This is an example of one company. At the same time, we're working with 2 other companies who are developing a similar array headset.
That's interesting.
Then 4 weeks ago, we basically closed a project on an industrial application, which has nothing to do with consumer electronics. So we're moving into the microphone test systems, where we are also, or we have developed together with the customers for the past 1.5 years, a test chamber using 4 of our MEMS speakers and a reference microphone to actually test MEMS microphones in an array solution. The reason why they've chosen us was basically the customization services we've been offering to them. So this was a joint development with this company. But the technical reason was that the MEMS speakers can actually, so this test chamber can self-calibrate itself, and therefore again reducing the test cost and the test time of the reference MEMS microphones. This is of course not large scale. This is not produced in the millions, but USound is actually offering the whole block of test chambers to that customer, and that's also what we can offer to other customers, a huge customization service to them. First products are getting launched right now, and the first test systems will be delivered to the end customers by the end of this year.
Just out of curiosity, would that be the type of application where you build a little chamber and the MEMS speaker emit the sound, and then what they're trying to do is to dial in the MEMS microphones for use in like industrial wear or alignment type measuring applications in factories or in cars and stuff like that?
Exactly. It's a test system for actually calibrating the MEMS microphones.
Okay.
You're right. Yeah.
Yeah. Cool.
Huge machine, like a table size, roughly.
Right. Okay. Sorry. Please continue.
And last but not least, just announced, I guess, 2 weeks ago, is the Indian company Vocally. Vocally is very deeply involved in augmented reality glasses. We see quite a lot of development in the segment of AR coming out of India. So they're building up a hub there to promote smaller companies, but also larger scale companies to build actually augmented reality glasses. And Vocally was one of the first that announced their product prototype stage at the moment, and they're moving into a pilot production and a soft launch. They've selected us for the form factor. So USound has developed 2 years ago, when we launched the Fauna, a dipole configuration using a MEMS tweeter and a ED woofer, what you can see in the lower picture here. And together with Vocally, we have optimized that system and matched it with their industrial design. And the main reason here was the weight. Trend in augmented reality is weight and size. So people don't want to have a piece of tech in their face. So you need to make sure that the temples are as thin as possible. And with our solution, we can actually offer the best audio quality by with a reduced form factor there. Second trend, of course, is power consumption in augmented reality glasses. Because of the form factor, the batteries is normally not as big as you would see it in a virtual reality headset.
Right.
And those guys will move to mass production again, also in Q1 2023. And at the moment, we are ramping up. With Vocally.
Okay.
So those are the four main projects we've won in the last couple of months and weeks. Full focus on that. There's a lot of more development going on, but since MEMS speakers are still a very new technology, people don't want to tell a lot to the outer world about their developments. You want to keep it as secret as possible to be then able to promote it accordingly.
Okay.
So that was the update from both a commercial perspective and then from a customer perspective. And I'd like to ask Andrea now to give us an update on what we've done in the past month from a technical perspective.
Okay, thank you, Paul. So let's start with the trend in the TWS space going toward two-way audio systems. So we have seen this happening in the latest flagship models of a number of smartphone manufacturers. We see this gaining even more momentum. And we have here an example. This is an Oppo Enco X2 headphone with a two-way system on this picture on the left. And you see there are two drivers. There is a woofer and a tweeter. In this case, the tweeter is working from 10 kilohertz upwards. So this is interesting for us because we have seen also in the latest Qualcomm State of Sound report that the interest toward TWS is, of course, very strong. The sales numbers are also growing nicely. And there is a more and more request for high definition and high resolution audio. And in particular, high resolution is a differentiator in terms of selling, and is an important selling point. So high resolution is all about higher frequencies up to the ultrasound range. So what we see our customer asking us to do is a system that enable the woofer to work up to around 2 kilohertz. And from 2 kilohertz onward, the tweeter should take over and goes up to 20 kilohertz, but even in the ultrasound range up to 40 kilohertz. So you can see here a comparison again on the form factor of these objects between, let's say, conventional electrodynamic tweeter and the Conamara series. And in this case, the Conamara is smaller in diameter, so 5 millimeter version of it, but most importantly is much smaller in the thickness. So we can go well below 2 millimeter, 1.3 at this point. In the roadmap, we will go below 1 millimeter. And this, you can imagine the space in that region of the product is important. So the smaller the driver is, the deeper you can go in the ear canal. But so generally speaking, you can have less of an headache having a smaller product. Plus the topics that Paul already mentioned, the SMT assembly possibility. So they can take our product, put them directly on a PCB and have an easier integration of the components. So this is very important for us, very interesting. And Paul, if you can go down the next one. This is our offering in that direction. The Conamara series, we have a 5 millimeter version and the 6 millimeter version. This one is a 6 millimeter version. So you can see in the SPL, we've done a lot of work in order to get the bandwidth much larger, up to the ultrasound range. And you can see in the SPL, these are two measurements, one with a standard 7-in-ever coupler and one with a high resolution coupler. And basically the one that should be taken into account is the higher resolution one, is specified up to these higher frequencies. And so you see the object can do very well up to this high frequency. The same can be said for THD, in this case plotted up to 10 kilohertz. So THD is well below 3% at maximum SPL on the whole bandwidth. This is done with an active linearization algorithm, ALA, and we can tune the piezo response so that the actual acoustic THD is lower, and in this case below 3%.
Does that mean that the piezo has a non-linear characteristic?
There are some nonlinearities relative to the piezo actuation, similar to what happened with voice coils. There are different type of nonlinearities, but similar effects, and we can account for them thanks to the understanding that we have on the piezo layers and the technology. We can apply modifications so that we can linearize the output response.
Okay.
Still, without this algorithm, the THD is below 5%. So it's not that this algorithm is mandatory for every application,
okay,
but it makes THD even better.
Yep. And just one more thing, the coupling to the 7-in-11, you've got sort of like a flat line from 1 kHz down to the bottom. So it's got a very tight seal there.
Yeah, this is a tight seal. Yes. So let me talk a little bit about our MEMS technology and the MEMS speaker technology in general. May be helpful to better understand what are the concepts behind this. So we have 5 pillars of our know-how and how to build these objects. And these are the parts of the technical development that we have to master in order to get these components developed in the way we want. And so there is a first one, which is the actual MEMS design. So how to design a high force, high elongation, and highly linear actuator on silicon. The MEMS technology itself, which is about mastering the piezo thin film state of the art and beyond. Mm-hmm. Then the assembly technology, so how to integrate these MEMS silicon chips with, in this case, with an acoustic membrane. We'll talk about this later in an assembly process. Then the ASIC design, so the power amplifier is a big part of this. So we need our own design in order to have an efficient driving, to bring down the power consumption, but also to enable advanced functionalities. So as you know, the MEMS speakers are using piezo or capacitive actuation. This is different than a voice coil, and it needs a different type of amplifier. And then in general, system IP, so what Paul was showing is also the result of the know-how of USound in terms of systems, so audio products, and we are doing a lot of efforts there. So next. So and here is how the object looks like in an exploded view. So you can see the object is composed by several components that are assembled with a typical microelectronics process, a pick and place process. And we start with a PCB substrate, which is the green element on the left. Mm-hmm. And we mount a MEMS motor on it, so a silicon chip that is available, that can do the forces and elongation that are needed for producing sound. Basically, this is the role of a voice coil in a normal standard loudspeaker. And then an acoustic membrane on top of it, mm-hmm. That actually produced the sound. And USound is the only company doing this concept. Also in the MEMS field, we have been the first moving on this concept. And we think this is the best way to get the best out of both worlds. One is the actuation using silicon, and the other one is the actual acoustic part of it. Mm. It is important for us because we can have a shrinking roadmap on the silicon part. As you may know, in silicon products, the main driver of the costs is always the footprint of the silicon itself. So how much silicon area are you using? So in order to get more and more devices on a single wafer, the typical way to reduce costs is to reduce the area of the silicon. And with this concept, we can do this. And we already did it between the Ganymede series and the Conamara series, where we have seen a shrinking of the silicon part of 50%, so half of the surface. But still, we have the same final dimension of the speaker itself. So the membrane remains large so that we can maximize SPL. And on the other side, the membrane, the driving driver for the cost of the membrane is not necessarily its surface. It's more the preparation and so on. So we can have a large membrane with a very affordable price. And so another very important part of using acoustic membrane on our speakers is how tunable it is and how functional it is. So we can design the torus and the plate so that we can meet the requests of our customers without having to redesign the silicon every time. So this is very important. So the modifications in the membrane can be small and can be fast so that we can respond to customer more easily. And we can also reduce and damp down some of the frequencies that are always present if you're working with silicon. It's quite normal to have some high Q resonant peaks that are not good for audio. So the membrane is a good way to damp this directly at the device level. And then the functionality. Yeah, please.
Just out of curiosity, is the membrane material space, is that something that you, as a company, USound researches materials internally, or are you making friends with material suppliers to push the limits of how thin and light and designing or manufacturing in 3 dimensions? Is that something in-house or external, or both?
Correct. No, we have partners for this, and we are using relatively standard materials, so PEEK and PI, for this kind of application. What's interesting is that we do have a much lower level of specifications for the membrane than a voice coil need to have. The reason is that, as you can imagine, in the voice coil, the membrane has also the role of mechanically sustain the coil and keep it in place. For the MEMS speaker, this is not the case, because the MEMS chip is already mechanically balanced and already produced a perfectly vertical movement that moves the membrane. So the torus that we do can be much softer than a voice coil. We don't have to take in account rocking modes, basically. So we can do a thinner membrane. We have less requirements, but we can focus on tune the actual acoustic response so that we can meet the customer specifications.
Okay, thank you.
And then the latest one is also functionality topic. So the membrane is quite a good element to interface with the environment. This is how we can get our IPX8 qualified, so 3 meter over 30 minutes underwater. So the membrane is protecting the MEMS beneath it, and it works just fine.
Okay.
And this a little bit more detail on the motor. So you can see the MEMS element is, in this case, an hexagonal silicon chip. We have 6 piezo actuators that are connected to a central piston, as we call it, through several springs. And this produced the vertical movement I was talking about. And as you see in this graphic, the movement is also stable. I mean, it's a system that is mechanically stable. And so we do this by using polarized PCT technology. Piezo technology is the state of the art at this point to produce large force, large elongations. we have a version of the process that is with one PZT layer and another version of the process with two PZT layers. So the more layers you can add, the more force you can produce. And we are doing this using a polymeric structural layer, which is helpful, again, to produce these large elongations. So I would like to tell that this technology is fully qualified per JEDEC and ESC standards. So we have a list of stress tests that are done on these devices. Mm-hmm. And in particular, shock robustness is always a topic for basically any MEMS device, but also for speaker, obviously. And I would like to point out that we have a very robust design. We are able to pass very demanding test conditions, in particular for TWS, the 2 meter, 20 time guided drop test. So this is a test done with a machine, and this guiding a jig on a stone substrate to create very high impacts. And then the other test is 1 meter, 40 drops in a tumble test. I think this is more for smartphones.
I think for the people watching, combined with the IPX8, this is often to protect the end user from washing their earbuds by accidents. They leave their TWS in their pockets and then throw it in the laundry, and that's it's not so much swimming. A lot of customers might not realize that, but tumble test and IPX8 is a lot to do with people forgetting these small electronics in their wash. So sorry I digress, but please continue.
Correct. And having a look in the future, we are now also starting using bipolar signals, which is important for power consumption. For this, we are getting maybe a little bit too technical, but this is the way for reducing the power consumption even more. And with this concept, we are looking to be lower than 0.5 milliamp, which is a very good target and would actually exceed the market expectation for DWS.
What does that 0.5 milliamps refer to?
So in this case, the quiescent current of the amplifier, which is the most important part of the power consumption for our system. And so being battery powered, we normally communicate power consumption numbers in milliamps.
Okay. Yeah. And when the device is outputting, what if I say maximum volume, maximum SPL, what does the figure look like then?
It's minimally higher. So the quiescent current is always the most prominent number. So I would say we would be like 0.7.
Okay.
Minimally higher.
So that's quite a significant difference from a voice coil speaker that you burn all your current on the coil. In this case, it's more a capacitive system where you're not really using any power, just whatever is lost in acoustic radiation.
Correct. This is a big difference, yes. Okay, so in terms of product, so you can see that the form factor is a big driver for us. On the bottom left, you can see a comparison between, let's say, a standard 6 millimeter electrodynamic speaker for TWS and the USound offering. So the difference in thickness is obvious. And the ability to assemble those parts using SMT, so fully automated microelectronic type of assembly technique, makes basically the design of the product for our customer easier, or they can use this space better and do smaller products if they wish, or use the space for other functionalities or simply for bigger batteries, right?
Yeah.
Next. So these a few words about the amplifier. As I said, the amplifier is an important part of our value proposition. It has been a barrier to entry in the market for us in the past because, as we already said, these type of speakers have a capacitive load instead of an inductive one. So for the amplifier point of view, this is a major change. So the standard amplifiers that are available in the market are not always working properly or in an efficient manner. So at USound, then we have designed our own amplifier. We are at the second generation amplifiers, and this one is the one that is going to be ready this year. Is an analog amplifier, class H, with a very small footprint, less than 2x2 millimeter, with the lowest power consumption that we have achieved. So in this case, we will be in sub milliampere, so less than 1 milliampere quiescent current consumption. Once we will implement also the bipolar signals, then we will be able to go below 0.5. And we are doing efforts also to integrate these amplifiers directly on the speaker. Basically, the speaker is already built upon a PCB substrate, so it is quite straightforward to take the backside of this PCB and put the driving circuitry directly in there. This is a good solution for some customers. Some other customers want to design their own driving system or put them differently in their product. But this is an important offering for us to all the customers that do not want to do that type of work.
Okay.
And at the end, we can say we have different offering for different type of TWS products. So the two-way system configuration, where we have an open earbud, we still need to use an electrodynamic woofer to actually produce the bass with a high leak design. The MEMS is perfect for taking over the tweeter function, in particular delivering, let's say, crystal clear sound from 2 kHz onwards. In the semi-open configuration, we have a version of our component that is 10 to 12 millimeter in diameter, so a larger object for full bandwidth semi-open designs. This is in development right now. Or for the occluded ear version, then we can use the 6 millimeter full range MEMS speaker for delivering the old bandwidth. So there are different configurations. Definitely, the MEMS is making its way toward more projects in the TWS space. We are offering, let's say, a wide range of solutions so that the customers can look and decide what is the best for them. So, and that's it for the technical part, but I can answer questions if you have any.
I saw on the, one of the first slides, the application of glasses, using it in glasses, which is a free field type of an application. What's the thought or the comparison between earphones and free field in terms of how the speaker will perform?
So in the free field, we use our MEMS speaker as tweeters. So again, there is a crossover. In the case of the glasses, I think we are around 3 kilohertz. So is important in this case, is a different type of development. Is a free field or near field sound application. Also, the SPL and THD requirements are different, but it's the same. Is basically the same object. So it is the same speaker. What we do for the glasses is quite a lot of acoustic design for the module itself. So the acoustic volumes, the ports, and the position of those ports. In particular, also for applying the dipole configuration to such a module so that we can improve privacy. So we can reduce the amount of sound leaking toward the environment.
I guess the question means also a little bit in the sense, is there a broader application for these speakers in free field situations? Is not something unique about the glasses that makes it work?
Definitely. So we see this. We see the interest of customers. Definitely, in an array configuration, we can produce systems for other type of products. So for televisions, for laptops, for cars. This is still in development, but there is definitely the opportunity to do that. So.
Yep. On a couple of slides, you mentioned that there's some X% less vibration. What vibration are you referring to in those cases?
So mechanical vibration, purely mechanical vibration. We have done characterizations, in particular comparing our speakers to electrodynamic speaker and balanced armature. And we see, thanks to the fact that we are using silicon, which is very light, the vibrating mass is very low. So you can imagine, in comparison to a voice coil, our speakers are 10 times lighter than voice coil speaker. So if a voice coil speaker is half a gram, our speakers are 50 milligrams. And this is an important aspect by itself. If you wear a TWS for longer hours, you would like to have a light product, but it means also the vibrating mass is very low, and so the vibration you produce is lower.
Yep.
It's about comfort.
So compared to the reaction force of the voice coil diaphragm, essentially. Yeah. And you said the Ganymede is used in the MRI scans because it has no magnetics, but none of them have any magnetics, right? That's the fundamental of it.
No, there is one particular version, as I mentioned, the UTP 2016. When you think back on the explosive view, you saw that there's a metal cover on top and bottom, but the UTP 2016 is using a plastic cover, and this is the differentiation. So in this very one version of the Ganymede series, we have no ferromagnetic materials.
Right. And in terms of low frequency, so open applications, you get the limitation is more than just the diaphragm surface area. It's displacement. So
definitely, these type of drivers are different than the voice coil. It means they have normally a higher resonance frequency, so it's a stiffer system.
Yeah.
Means we can produce enough SPL also in the low region. What is not happening is if the design is leaking or open, you don't have the overshoot of the voice coil that is typically happening. So in that sense, this is still a limitation, but if you see, so from the Ganymede series to the Conamara series, we made an improvement by 6 dB in the bass, and in the next series we will have additional improvement. So
that's by virtue of reducing the system stiffness.
It's by adding more force, actually, and also using the stiffness. Yeah, correctly.
How about classic sort of X max? is it so the whole thing is only 1 millimeter? So the X Max is not huge. Just say if you were just trying to throw tons of power at it to get displacement low frequency.
Correct. No, we are not in the millimeter range. It's a couple of hundred of micrometers. Obviously, if we will design a object capable of such higher displacement, we will have to do also a thicker product.
And there was one slide there showing the woofer with the tweeter. It looked like that was sealed. Have you got the low frequency just transmitting straight through your device, or is there a pathway around that?
There is a path. There is a path.
Yeah. And you already mentioned that one, power consumption and low frequency. Awesome, thanks.
Okay, that's and just so commercially, Celtec's still distributing your products for you and representing globally?
Yes.
So,
yes. Celtec is still is still one of the distributors we have. There are a couple of more in Japan, Korea, in mainland China. I think I've mentioned the last time, we've opened our own office in Shenzhen with the local team there, and we also very active in the US American market with people on the ground there in the San Francisco area.
Okay.
As well as Europe, of course. That's where we're from.
Yeah, great. All right. Well, I think that's good for today. So I encourage everybody to shoot your questions in the comments below. Ask us anything you like. And just thank Paul and Andrea. Thank you for taking the time to update us on your products. It sounds exciting, and look forward to another catch up whenever something's new. Let us know.
Sounds good. Thanks for having us.
Okay. Thanks, everybody.
Thank you, David. Thank you, Simon.